Hello and welcome back. Now we're going to be doing factorizing by grouping in pairs. This is the method that many people use as a intermediate step before they dive into factorizing quadratics. Okay, so think of this as a precursor skill for something called the PSF method. You'll see that come up sometime next term if you're following along with my class, but for the moment you're going to see this primarily just used to factorize expressions that look a little bit weird, that don't have a technique, okay? So thinking currently what we've done is we've done common factors, okay? Then we've done difference of two squares, okay? And now our third skill with factorizing is going to be grouping in pairs, okay? Or often just called factorizing by grouping, okay? And you'll see something that is quite interesting that'll pop out as we go along. First thing, as a recap, you need to make sure that you look for common factors in all of your terms, okay? And they're the things that you're going to drag out. You could rewrite this as 2 times x plus 4, oops, sorry, my apologies, I've done the same thing, plus 2 times 2, and you'll see that we have a common factor of 2 on both terms, and that's what we're going to drag out. Okay, so it'll be 2 outside of x plus 2 here in that first one. So going into the first question, okay, what you're looking for is you're looking for your terms to have a common factor of both. Okay, a common factor of a common factor of x plus 3 on both of them. Okay, so this is just like me factorizing out the factor of 2 up here. Okay, however, this time we're going to factorize out the whole thing of x plus 3. Okay, not just an x. They both have an x plus 3. So I'm going to rewrite the x plus 3 at the front. And what I want you looking at is with this x plus 3, I am left with just an x on that first term. So I put a bracket there in the second thing, okay, just like what I did up here, putting my bracket as my expression. And because I've got an x plus 3 here, I'm left with my positive y as my second term. Okay, so now you'll notice we've ended up with a binomial product here, with the common factor being this x plus 3, rather than it just being a single number or a variable like x or 2 or something like that. It's now two things. Okay, have a look at example 2 and get ready to have a little bit of a play with it. I'll get you to pause here and attempt, but I'm going to dive into it right now. So you're looking for things that are common across both, okay? All right, so now in this particular example, you have the example of 5 plus x and 5 plus x on both terms. That's the common factor that we're going to remove out. Okay, so now removing the 5 plus x out, ask yourself inside of this bracket, what am I going to put here? Okay, well, if I remove the 5 plus x from the first term, I'm left with an a squared. Okay, and if I've removed the 5 plus x from the second term, I'm left with a b. Okay, a positive b at that. And that's how you factorize using this particular thing. Okay, now our third example here, okay, again, looking for something that is common. You have an x plus y and an x plus y that is common on both. So that's going to be our common factor. Okay, I should have said you should have paused here before you jump in, but that's okay. Now, if I have a common factor of x plus y, what am I left with on the first term? I factorized out an m to be left alone. And now same thing, I've removed the x plus y and I'm left with, in this particular second term, a negative n, okay, to be able to work with, all right, minus n being the second one. Now, why is this called grouping in pairs? We haven't really grouped things in pairs just yet, so I'll show you in the last example where its name comes from, okay? All right, so first things first, if I look across this particular expression, I want to go through my checklist. Have they all got the same common factor? Well, not all of them have a 2, not all of them have an x, not all of them have an m, and not all of them have a y. So they don't have common factors across all of them, okay? Then I check, well, have I got something in the form something squared minus something squared? And no, the powers of all of these are all 1, okay? So I can't go and apply a perfect square. A difference of 2 squares. So what do I do instead? Now I look at each individual pair of components and I go, well, what is common between them? So you'll notice this first particular pair have a common factor of 2. If I remove the 2, I'm left with an x on the first term and a minus y on the first term. And then looking here at my second pair, noticing that we're grouping them into pairs now, they both have an m. So looking at this particular example, if I remove the m in the first term, I'm left with an x, and in the second term, I'm left with a minus y. So now, rewriting that out so you can see what I've done as my actual step of working, I'll have in my first term 2 outside of x minus y plus m outside of x minus y. You'll see now that we now have our common factor, okay, sorry, our common factor like we had in our previous examples of x minus y after we have grouped in pairs. So we're going to factorize that out now. Now, putting it all together, I'm going to have an x minus y left with, if I remove the x minus y from the first term, I'm left with 2. If I remove the x minus y from the second term, I'm left with m. So 2 plus m. And that's your final answer. Okay, so that's how you apply the grouping in pairs. Think of this as a precursor skill leading into what's known as factorising for quadratics in a little bit. Okay, thank you very much.